If you draw the altitudes of the triangle where those intersect, will give you the orthocenter. Okay, this is the hardest one to draw. The altitude of a triangle is basically going to take your vertex, and you want to go straight down, perpendicularly down to this bottom side, your base, basically. Okay, so what I like to do is it's kind of easy to see here because I can see my 90 degrees. I'm lining up with this bottom side down here. If it's hard to see where your 90 degree is, you may need to use a ruler on top of your protractor. You basically want to slide along this bottom side here, this base, until your 90 degree line is, you're lined up down here with your base, and our 90 degrees is going through that vertex. Okay, so I'm going to draw a little line there. And come over here, use that straight edge to just bring that on down. Okay, this would be an altitude. It's going from that vertex straight down so that it is perpendicular to our base. Now we have to do that with all of our sides. So I want to line up with this side, and I need to know where is the 90 degree line, the perpendicular line, going to go through that opposite vertex. So I put my ruler on the 90 degrees there, and I need to slide, making sure I'm staying lined up here, lined up on that side, and I want to slide along that side until my 90 degrees is hitting that opposite vertex there. So this is the hardest one to draw. I'm going to mark right there, 90 degrees is going through that vertex, lining up with that side there. Hardest one to draw for sure. On a test and on a quiz, I will never ask you to construct this one, but it's good to know. Okay, so we have to find the last perpendicular line that's going to hit through that vertex. So I'm going to line my protractor up on this opposite side here. Okay, I'm going to get it as close as I possibly can here, using a ruler or something to say, okay, there's my 90 degree mark. That was pretty good. All right, I'm lined up over there on that side over there. Make sure I'm straight over there. Okay, 90 degrees, it's pretty close. Okay, sorry, a lot going on here. Okay, so it's going to be slightly off. I mean, you got, human error here where it's hard to keep everything straight. It's pretty close though. Alright, so where all these altitudes are crossing, that right there would be our orthocenter. Remember, orthocenter, hardest one to construct, and he doesn't have any special properties really to speak of, okay? So the only thing he's really got going for him is the fact that this is a perpendicular line. It is making a 90 degree angle going through that vertex there, okay? So we're going to dive into some of these and look at some more specific cases with these. Okay, so here we're using the property of the centroid. Remember, the property of the centroid is the 1/3 from the midpoint to the center will be 1/3 of the whole median. From the midpoint to the vertex will be 2/3 of your entire median length. Okay, so they tell me S to Q is 8. Okay, so looking at this picture here, SQ, you can imagine that seems to be the longer segment there. So I'm imagining splitting it up into thirds. I'm imagining splitting it up into 3 equal pieces. I see that that's my 2/3 piece. This down here would be my 1/3 piece. And you can kind of visualize our 3 congruent pieces. So if S to Q is 8, 8 divided by 2 means that each of these pieces had to have been 4. So this piece down here is also 4 because we're splitting into 3 congruent pieces. So when they want from Q to W, we see QW here is 4. When they say SW, here's S, here's W. So they want the length of the entire median, okay? So 4 plus 4 plus 4, or you can say 3 times 4, because we've got our 3 congruent pieces and each piece is 4. We understand that SW is 12. Okay, so there's your 1/3, 2/3 property there. Alright, a lot going on in this figure down here. There are 3 paths in our triangular park. Each path goes from the midpoint to the opposite corner. So we're going from midpoint to vertex, midpoint to vertex, midpoint to vertex, okay? So that is literally the definition of a median. They have basically told us, hey, we have drawn the medians here by how they explained how they've drawn these. All right, so they tell me from S to C is 2,100 feet, or 2,100 feet. S to C is right here. So that is an entire median there, okay? So I need to visualize splitting this up into my 3 congruent pieces. Be one piece there, probably about right in there, be my second piece, and that would be my third piece, okay? Splitting it into 3 congruent pieces. So if I take this, SC is 2,100 feet, and I want to divide that up into 3 equal pieces, then we would see that each piece is 700 feet. So 700, 700, 700. So they're concerned with P to S. P to S is just my 1/3 piece, so that'd be 700, easy. P to C, we see that that's our 2/3 piece. So we have 2 of these 700-foot pieces. We understand that that's 1,400 feet there. All right, now this one's a little bit tricky. They're talking about TC, BC. They tell me that from B to T is 1,000 feet. Look at your figure. B to T, this is not using our 1/3, 2/3 piece. This is using the fact that T is my midpoint. And if T is my midpoint, what's true about these 2 pieces here that I've highlighted in blue? Well, it should be that they're congruent, right? Because midpoint bisects it. So if BT is 1,000 feet, then TC is also 1,000. And when they say BC, they're talking about all the way across, okay? So BC would be 1,000 plus 1,000, or 2,000 feet, okay? All right, and then they tell me that PT is right here. They tell me that PT is 800 feet. So notice that it's different than the purple one, okay? But that's still part of a median. So I want to try to split this median up into 3 congruent pieces. Okay, so there's 1/3. Here's another third. And this would be my third, I guess you could say, okay? So PA, P to A, that's my 2/3 piece. So I have 2 of these 800-foot pieces, so P to A would be 1,600 feet. TA is all the way across that entire median. So I have 3 congruent pieces, each of those pieces being 800, so we understand that that entire median then is 2,400 feet. So understanding the different parts of the 1/3, 2/3 relationship in your centroid. Okay, now orthocenter. We've already talked about the fact that he really doesn't have a special property, but there is something kind of special about just kind of how he's drawn. It tells me that Z to C is an altitude. So remember at the beginning of this video we talked about how you construct an altitude. It has to go through the vertex and it has to come down so that it is perpendicular to this base or this side of the triangle. Now they're talking about angle CYW, so from C to Y to W, so ultimately they're talking about this angle down here, which I'll mark there, and they're telling me that angle Y basically is 9x plus 38. And then they go on to tell me some information about angle WZC, from W to Z to C. WZC is talking about this top angle up here, which I'm going to mark with 2 congruence marks. And they tell me that that angle can be represented with the expression 17x. So what you have to visualize here, I'll kind of outline it first so that maybe it'll make more sense. You kind of have a triangle within this bigger triangle, okay? So we have this, which is our altitude, which I've highlighted in blue, and we know that he's 90 degrees there. They're talking about this angle, okay, which you can see we're looking at this triangle that I'm outlining in blue, okay? It is a fact because of linear pairs that if this side's 90 degrees, then this side does have to be 90 degrees because they are on a line, they have to make 180. Now, looking at this triangle, we know that this angle is 90 degrees. We have some information about this angle, and we have some information about this angle. What do we know about the angles inside of a triangle? They add up to equal 180 degrees. So we're going to take the 17x plus the 9x plus 38 expression, plus the fact that this guy is 90 degrees. You have to add up all three angles added together will equal 180 degrees, and we're going to solve this equation. Okay, so if we combine like terms here, they give us 27x. Combine like terms here, we get 128. We'll subtract that 128 over. Bring down our 26x. This gives us 52. Divide. And we see that x equals 2. Not your final answer though, okay? Because they're asking us about the measure of angle WZC. WZC is talking about this top angle. Now that we know that x is 2, I'm going to substitute that in. Everywhere I see an x, I can plug in a 2. We multiply that out and see that this angle up here is 34 degrees. So even